Welcome to the Slurm User Group Meeting 2022, our next session. We have a couple more sessions throughout the rest of this day. My name is Nick Ihli, and I'll be sharing a session, Cloudy with a Chance of Dynamic Nodes. We have all these sessions on our YouTube channel, so you can go and view that and see the rest of the agenda for the rest of the day. As we go through this, please ask questions in YouTube's chat. It is being moderated by some SCEDMD staff. In my presentation today, we're going to kind of hold the questions mostly till the end, as I foresee that most of the questions that come up will be answered throughout the presentation. So we'll pause at the end then and have some time for questions there. So as I mentioned, my name is Nick Ihli, and we're going to be talking today about dynamic nodes. They're somewhat related to cloud based on the specific use case and kind of how you're using them. And I'll also share a little bit about some new items regarding cloud that we have done. I do got a shout out to Nate Reaney about this title. He's the one that came up with it, and I like the cleverness of it. So previously, when you'd be adding a node, or what I'd call like adding a static node, and the process you'd go through would be to stop the Slurm control daemon, update the Slurm comp file with on all the nodes in the cluster, and you'd add in all the node configuration that you would need. Then you'd restart the Slurmds on all the nodes, and then restart the Slurm controller. That is a process you have to go through, and there's some great benefits to that. So part of the reason that this is done is that the Slurm controller, SRun, and the Slurmds are able to read in from the Slurm comp file the node configuration, so they know who to communicate with when they need to. Also, this enables hierarchical communication with a configurable fanout, which provides better efficiency for large clusters as well as large MPI jobs, and ultimately really provides a less overhead on the controller. So I want to share a little bit about Fanout and talk a little bit about that, and then you'll see why this is important to understand and how Fanout works as we talk about dynamic nodes. So there's really two kinds of communication that I'm going to focus on with regards to Fanout. One is the ping communication from the Slurm controller to the compute nodes. That's how it knows that the Slurmds are alive and well. With Fanout, the Slurm controller, instead of going and communicating with every single Slurmd out there, it's able to fan this out. So it might go to 10 Slurmds, and that would go to 10 Slurmds, and they would all go to 10 Slurmds, all throughout, and forwarding that communication throughout the environment to offload that from the Slurm controller. Also, SRun communication, ultimately after a job submitted, SRun will forward the credential with that task information to the Slurmd, and then the Slurmd is able to forward that to all the different Slurmds that are a part of that job allocation as per that fanout. So it's really able to make things that much more efficient and optimized, especially on larger systems and large jobs, so that there's not a single point of impact on the Slurm controller or on a single Slurmd, where every single Slurmd would have to be communicated with. And so that's Fanout, and the method that we have for adding nodes, Fanout is one of those reasons why it's done the way it's done. However, that method of adding nodes doesn't always work for every single use case that's out there. And so we've added a new capability in 2205 of Slurm called dynamic nodes. What dynamic nodes allows you to do is add and delete nodes from the system without adding them into the slurm.conf file, restarting the Slurm controller, or the Slurmd. So this handles a number of different use cases. Here's a couple specific ones. And this first one is really kind of the instigator of it from one of our customers, where they had multiple dynamic clusters that grow and shrink based on demands from users, and some users kind of create their own clusters and are able to move those nodes around from one cluster to another as that demand is needed. Another capability of maybe you need to just temporarily add a new node to the environment for a couple days, for a week, and to update all the configuration, restart everything, and then when you're not needing it anymore, remove it from the configuration, restart everything. That can be overhead and burdensome when you're constantly doing that, sometimes on a daily basis. There's even cloud services and cloud use cases that can make sense for this need to add and delete nodes as needed. And so that's kind of that instigator behind creating the dynamic node capability. And so to enable dynamic nodes, there's a couple of configurations that you have to do. First one we'll talk about is in the slurm.conf file, tree width have to be set to 65533. What this basically does is it disables fanout. Since the slurmds and srun is not able to pull that information from the config file of knowing the node configuration, we have to turn off this fanout. And what instead has to happen is that the dynamic nodes are going to rely on this alias list for communication. So the slurmds and srun are going to get the alias list from the Slurm controller. The alias list is the node address information that it gets from the dynamic registration of that node, and then it forwards that on to the srun and slurmds that are in a job allocation. And so that alias list, there's actually a variable that you can look at to see that alias list. So it's important that it's understood that with dynamic nodes, you don't have that benefit of fanout. And so that is a trade-off if you're going to go that dynamic nodes route. It's important to understand that and know that. And so it is our recommendation that even though we have the dynamic node capability, if your nodes are kind of your more traditional static nodes, you're adding a new rack to the environment, I'd recommend do it the normal way and not adding that rack through the dynamic node method, unless it's going to be those nodes that you are adding and deleting consistently. The second configuration is the max node count. So this is going to set the total number of nodes that can exist in the system. And so this is minimally set to the number of nodes that are in your slurm.conf file. So if you're going to add dynamic nodes, you need to make sure to set that above what that amount is in your slurm.conf. If you don't put anything in there or don't set a max node count, it will just automatically set it to be the total amount that's in your slurm.conf already. So any dynamic registrations just won't work because you're hitting that max node count. So that's important to kind of estimate what you think that amount is that you're going to be dynamically adding. Third, we have the select cons trez of your select type is the only supported select type for dynamic nodes. So if you're using cons res and you need to use dynamic nodes, it would be time to migrate to using cons trez. And then finally, the cloud DNS slurm control D parameter must not be set. So this is one that if it is set, it disables that alias list, which is needed for the srun and slurmds to know how to communicate with the nodes. The second, so there's two ways to add a dynamic node, and it's important to understand that this is different than our power saving module for cloud, where we are resuming suspending nodes. So Slurm isn't automatically creating nodes in any way. This is something where you're manually creating the nodes, or you have some service that is going to create these nodes, and they're going to then have this dynamic registration with the Slurm controller. So it's important to understand the difference there. So the first way to add a dynamic node is dynamic registrations. Basically, you start the slurmd with a -z option, and that will tell Slurm that the node is a dynamic registration. And then you give it the --conf option, which is basically the node configuration that you would have done in the slurm.conf file. You're just doing on this conf line. So you're going to give it all those parameters of hardware topology, so on and so forth on that conf line. There's a few options that are not allowed in the --conf. The one you really got to worry about is the node name, because it's getting the node name automatically from the dynamic registration. If you do not provide hardware topology, CPUs, cores per socket, etc., then slurmd will use the hardware configuration that it detects automatically, which you can see doing a slurmd-capc. If you do provide any hardware topology, then it will use what you provide as the hardware topology instead of adding on to what is automatically detected. So it's going to, whatever you define will replace what is automatically detected. So here's an example of kind of how that looks. So if I ran slurm d-cap-c, this is my node information. I get my node name, CPU 16, boards 1, cores per socket 8, real memory, etc. If when I start the slurm d with a -cap-z and do it the conf line and just do aggress equals GPU:2, this is not the CPU memory topology, so it's going to add this to my node configuration. So I still have my CPUs, my boards, sockets per board memory, but I also add in, it's going to register with the gress equals GPU:2. If now in the next example I do a --conf and give it CPU 16 and change the real memory and do a gress, you'll see there the node will register with what I requested versus what was determined by that slurm d-cap-c. The second way to add a dynamic node is using S-control. Now this only works for nodes that are going to be state equals cloud and state equals future. Now one note about state equals future, I personally feel that really state equals future is kind of becoming obsolete with dynamic nodes, except for if you need to use that some of those capabilities that might be just in future versus the dynamic node capabilities of with Fanout and whatnot. So important to understand that. But to do this, you just do S-control, create node name, and you give it the node configuration and of course a state equals cloud. Again, no node is actually registered or started on this. So all you're doing is basically creating like a node configuration object inside of the Slurm configuration. And this is a node that is going to be powered off, idle, and cloud node. And so it could potentially be resumed at some point. And at that point, your resume script will go and do what it does to add the node and create the node, and then it will communicate with the Slurm controller. So it just gives you the ability to add more node definitions. So you've spun up your cluster inside of the cloud. You have a certain amount of defined node configurations in there. Now you decide you've kind of hit that limit, and you keep running into that limit, and you want to add more nodes in the cloud that are potential to be auto scaled instead of having to add those in the slurm.conf and go through that process of restarting everything. You can do the S-control create node name and add these further cloud definitions through that method. And here's an example of just kind of what that looks like. But just like the dynamic registration, Slurm in all this is not creating the nodes for you. You have to have some service or some method that's going to be doing these two methods of adding the dynamic nodes. Configuration is just like you would normally have. You have Configless that you can use, or you can just continue to use a local or shared slurm.conf file. So really no difference there. The one point that's important to understand on this piece is if using Configless and aggress.conf, I recommend to use the autodetect NVML in that central aggress.conf, because you don't know what those future dynamic nodes are going to be, and so you'd have to have them in that aggress.conf individually, and that's you're not going to know that necessarily. So if you don't do the autodetect, then the other option is to have a local aggress.conf on your dynamic node, either with autodetect or the specific node configuration. Now you've added your nodes. How do we get those into partitions? That's kind of the next question that I'm always asked about this. By default, nodes are not added to any partition. So if you don't do these next steps that we go through, your nodes will not be in a partition in the environment. So there's really two methods to do that. The first method is setting nodes equals all on your partition. It's very open partition where every node in the environment will be in that partition. Even dynamic nodes, as they are registered, will be put into that partition. So pretty basic there. The next method is to use node sets. For those unaware, node sets are ways to group your nodes together in a with common features, and then you can use those node sets to refer to those group of nodes versus having to list out all those nodes. Like in a partition, instead of having to list out 100 nodes, you can just list that node set, and you've already defined that node set somewhere else in the configuration file. So here I have an example of a couple of node sets, NS1 and NS2, and then I have 4 partitions, all P1, P2, and P3. So if I start my dynamic node with slurm d-cap z, and I give it the conf line of the feature of F1, then my node, when it registers, is going to be placed into 3 partitions. All, because of nodes equals all. It will be also put into P1 because that is all NS1 feature, or all NS1 node sets, as well as P3 because that's also NS1. And my my node registering as F1 will be put into the NS1 node set. So that's kind of the method that you would put these dynamic nodes into the different partitions that you have set up. Now your node's been in there. Now you're going to remove that node for whatever use case you have. To remove those dynamic nodes, you have to manually delete the node, or some service that would be deleting the node. Just using scontrol delete node name, and then you give it that list of nodes that you're going to be removing. Important to note, nodes can't be deleted unless they're idle, and you need to clear the node from the reservation. If there's any reservations that have that node, if you don't, the node will come back. This next step is not really necessary, but I recommend it. You need to stop the slurmd on the compute node. It's not going to re-register on its own by sitting there, but if it got restarted, it would then re-register. So I just recommend go stop it, you remove it, tear down the node, whatever you're going to do there. So that's dynamic nodes. We'll cover some questions at the very end on any of those pieces with dynamic nodes. We'll jump into a couple small cloud things that I want to share, and then the rest of the time we'll do with questions. With 2205, we have added just a few little minor cloud changes that I think are important to talk about. One is how a cloud node that's powered down but idle shows in the database. And so with regards to S-report, here I have a report that is showing my usage and CPU minutes. Now, previously what would happen on this small cluster that I have, that in this case hasn't been used for a little bit, it would have showed that all my usage was idle. And so when you're showing those reports, it's true, yes, it was idle, but it's a little untrue at the same time because those nodes were not powered up. I wasn't being charged for those nodes on my cloud environment. And so in this case, I only had my controller up for like a week and wasn't using any resources. So now with plan down, you can look at this and delineate between what was actually sitting idle where the node was powered up and was idle waiting for jobs versus when it was down in the sense of no workload on it, idle, powered off. So that new plan down state will be very beneficial for your reports on the cloud environments. Second is Configless. So Configless we've had in Slurm for a couple of releases now. It allows you to have Slurm push the configuration to the compute nodes, and you don't need to have a slurm.conf local on that compute node or shared that it's getting across a shared file system. But now what it also does is it will take include files that are in your configuration and push those along with other slurm.conf files. And so this makes cloud configurations much easier, especially hybrid. Because before this, with cloud, you would either need to bake your slurm.conf file into the image that you're using for your compute nodes when those are spun up, or have a shared file system. When your environment's all in the cloud, that's not a huge deal because you kind of control that really well. But in hybrid, to do a shared file system across the on-prem slurm.conf on the controller to the cloud, really not recommended to do. So the next thing you have to do is bake it into your images, and that can be difficult if you're constantly changing your slurm.conf, especially early on. And most cloud configurations that we work with, they use an include file in their slurm.conf. So this new capability of pushing the include files to the Slurm configuration with the Slurm configuration to your compute nodes really will make hybrid a lot easier. So if you have in your Slurm.conf an include like a cloud.conf or something, that will make life a lot easier for those that are doing hybrid. And finally, we'll close with an update with our cloud partners. We continue doing a lot of work with our cloud partners. You've heard already in some of the earlier presentations, some of them, and the many great things that they're doing with customers. First, I'll talk about Google Cloud. They have recently released an HPC toolkit that is now integrated with our version 4 of our Slurm GCP scripts, and they're working on doing that integration with V5, which was just released in May. So our V5 scripts, many improvements and changes and updates to capabilities within how Slurm GCP works with Slurm works with GCP, and the Terraform scripts around it. Here are a couple of note. Improved error handling and debugging with the resume suspend scripts. This makes it much easier to understand why you didn't get your resource. Was it a stock out issue? And you can get kind of more details to investigate further of why maybe the resume script or suspend script failed. The accounting data that we have in Slurm, the S account data, is being dumped to BigQuery now. So you can take that data in BigQuery and then do further analysis of that data, marry it with data from like the billing, and then from there you'll be able to understand maybe better how much jobs are costing you. We've also updated the Terraform to be more of the source of truth for the infrastructure and Slurm configuration, where you can go in and make changes to the configuration without needing to completely tear down the environment and then rebuild it back. You can just make those changes at the Terraform level, do a Terraform apply, and everything will get updated within the environment. This also enables the ability to, if you've tear down your environment, but you still had compute nodes out there waiting to be torn down by the suspend script, but that never happened, and you already tear down your controller. This will also tear down those nodes for you, so don't leave any hanging resources out there, wasting money for you. We've also updated our hybrid configuration to make it more turnkey, automated some of those steps that you have to do in creating a hybrid environment, and many more. So go to that website; you can see more about it. And Google's continuing to sponsor further development on the Slurm GCP scripts that we are doing. Next, AWS Parallel Cluster 3.2 now supports memory-based scheduling. So this link here, you can go read more about that. They also have their new version of Parallel Cluster coming out soon, where they're going to be upgrading to use Slurm 22.05. They're going to be making it easier to enable Slurm accounting and make it more flexible to map the Slurm nodes to the heterogeneous EC2 instances that they have, and provide better support for cost and capacity optimized strategies. So you'll see a lot of updates there. Also, in Slurm 2302, they're sponsoring further development as well. So you'll see some continued enhancements on the cloud side of things, thanks to them. Then Microsoft, we continue to do a lot of collaboration with them with Slurm on Azure Cycle Cloud, and the number of customers that are using Slurm on Azure and Cycle Cloud. This link here is the official GitHub repo for their project, so go take a look at that and get more information there. So questions, go ahead and hold for questions at this point. Okay, so one of the questions, will the registration fail or will slurmd abort if the conf option doesn't match what hwlock reports, thinking of nodes that might have lost a DIM due to a hardware issue, for example? So you're going to have the same issue that happens when the configuration line in the slurm.conf is different than what is showing up, where my understanding is it will register but be in a down state, and so you can go and fix that. Another question, could I use this to update already existing nodes or remove add only? So yes, if you already have nodes that are configured in the Slurm configuration file, those are not dynamic nodes. So you wouldn't be able to delete those nodes or remove them in any way. They have to be added as a dynamic node to be able to have that control and do an S-control delete on them. The second question to that, would it be ideal to dynamically update node CPU config when CPU layout changes? So for that, what you would need to do is basically re-register the node, is what you would do at that point. So you would delete the node and then re-register the node as that new configuration of the hardware. What exactly are you trading off by choosing dynamic nodes versus Fanout? So it's basically performance. So those two main benefits are large clusters and especially large MPI jobs. You're going to see a faster, a better performant experience when you're using Fanout. There is also just in general better performance because the Slurm controller is not as burdened in having to communicate with every single node. So you have a cluster of 20 dynamic nodes, totally going to be fine. You go thousands and thousands and thousands of them, and you're doing large MPI jobs. You need to. That's where that performance difference might be there, and you're going to have much more network traffic as that Slurm controller is having to communicate with all the Slurm Ds, and the Slurm Ds, when they're communicating with each other, are not able to do that fan out. Okay, it looks like we are kind of wrapping up on time for questions. If there are other questions in there, feel free to reach out to us and we can answer those for you. Thank you for your time today, and please stay and continue to watch the other few sessions that we have the rest of the day. Thank you.